demonstrations, and these are ones that we picked up over the years and illustrate some interesting things about chemistry. Okay, whether it's showing something or it is actually showing a change in something. Okay, so for example, I have some red wine here, and I'm sure there'll be a few teachers who will be having some red wine. So there we go. That's a nice red wine. Okay, I'll put that down there. Now, obviously, if you're under the age of 18, you're not allowed to have red wine, are you? Okay, so you probably should have some water. Okay, so that's what you should do there. You should have some water. So I put my red wine into water. Okay, guys. Now, obviously, with younger children, you tend to want to have milk. So, with a bit of luck, I could turn my red wine into milk, and then you can have a glass of milk, guys. Okay, that's quite nice. Personally, in the autumn, I like to have a nice blackberry milkshake. So, with a bit of luck, I could turn my wine into blackberry milkshake, which is quite fun, isn't it? And of course, sometimes if I'm nice to my children, I let them have lemonade. Oh, there we go, we have some lemonade. Okay, guys, so that is a nice example of the things that chemistry does. Okay, it turns one thing into another, and it also helps us introduce things. So, that's a very fine example of what chemistry does. We turn one thing into another. It's really quite cool. Now, yeah, could you be so kind as to move that? That's lovely. So this is quite nice as well. This is another idea of showing things. This is another solution. Of a bit of luck, I can make it go blue. Okay, there we go. So we'll just leave that there for a bit. My lovely blue solution. So what's the next one? Oh yes, this one. Yeah. Which one have you changed that? That was blue. So you can't trust these. No. Turn you back for a second, and they ruin stuff. Okay. There we go. I'll leave that there for a second. Okay, cool. So I thought what we'd do is have a £5 note.
No. And
I'm going to set fire to it.
No.
Because we get paid too much in Frensham, isn't that right, Louise?
No.
You turn the light.
No.
So a bit of luck, I've soaked my £5 note in ethanol. There's ethanol, and I've got the match, and on the floor.
Are your fingers covered in?
I think my fingers are. Rennie, do you mind just lighting one of those? And I'm going to set fire to my £5 note. There we go, because we do get paid too much money here, don't we?
Yeah, we do.
Oh, but because I'm a chemist, okay, I kind of know the way around this, and I did put ethanol on it, of course I did, and that's what caught it on fire. But what I did is also put water in it, yeah, and the water used the heat up from the ethanol, and therefore it didn't catch fire. Can we do that one again?
Yeah.
Good? There you go. And lovely colours. You also got a slight worry, don't you, that it will actually catch fire. There we go. So lovely example there of the heat that chemical reactions give us and how we can cope with it. Now, what's that? Are they really? Now, one thing that's is that you? Have you changed my solution again?
Boring.
Of course, so the lovely thing about chemistry is some of the year 10s have been doing with me is this idea of identification. And what you do here is you exploit the idea that some compounds don't dissolve in water and they give beautiful colours. So with a bit of luck, you get this beautiful yellow colour, okay, of lead iodide, and it's just absolutely gorgeous. It's just pretty to see more than anything else. Okay, that's an example of a precipitation reaction where two chemicals go together and get a beautiful colour. Thank you. Yuck. So the other interesting thing you can do with chemistry is you can decide when something happens. If you understand the chemistry, you can decide when a reaction happens. Now, so some people would call this bucket chemistry in the sense that I'm not really measuring anything out. And that's kind of okay because I kind of know what's going to happen. There we go. So, I have to get rid of those bits. There we go. So there we go. Nice, pretty blue colour. Anyone recognise the name of that chemical? Copper sulfate. And I got it with magnesium powder. Now, those of you probably from year 8, maybe above, will know about displacement reactions. The more reactive metal in place of the least reactive metal. Now, here, of course, copper is lower reactivity than magnesium, and it really should be reacting, but it's not reacting, okay? All right, which is quite annoying. But it means we can show the exothermic nature of this reaction. Okay. Actually, if you just put your hand just above that, you feel it? Ever so slightly, you can touch it. So what am I going to do now? The reason why it's reacting ever so slowly, because it must be quite a humid day. There's enough moisture in the air or in the chemicals for it to try to react. But what I can do is I can put a little bit of water in it, and then it allows it to react. Okay, and it gives off quite a lot of heat. And because I've got it in a little bit of water, all that water vaporizes up and gets hot. So it must be over 100 degrees in order for this to boil that water away. And you get this idea there of this lovely displacement reaction, and sometimes the technicians get annoyed at us because they call this the Kaupat reaction. I don't know why they call it that, but there we go. And of course, the brown is a copper metal that's being formed. And it's a nice one to show the fact that you get a lot of energy changes in these reactions. Cool, so that was a nice displacement reaction that gives us very pretty colours. And a lot of heat. Thank you.
Yay. We know what it is. Yeah. What is this? I don't know.
So, again, it's this idea of knowing when your reaction starts and knowing ideally what to expect. So this one here, for those of you in year 10, you'll know about this reaction because you have to learn it for your exams.
Yeah, we do. Come on,
Oh, yeah. So what I've got here is hydrogen peroxide. So those of you in your life that may bleach your hair, okay, you're probably going to use hydrogen peroxide. That's what your hairdresser will use. This is basically 100% hydrogen peroxide. The hydrogen peroxide that you get in hairdressers won't be as concentrated as this, and it's very good. It's good in the sense because it oxidizes things, and it breaks down over time. It breaks down into water and oxygen, and so we have to tend to store this in the fridge over the summer holidays to slow it down and take the top off. Now, so I'm going to try to release all of that oxygen, okay, and trap it. Okay, that's what I'm going to do. Let's have a go. And this is sometimes called elephant's toothpaste, and it's a great reaction. And all that oxygen is coming out. And again, you can see the water vapor, very, very hot, very exothermic, and again, a nice bit of fun. Still going. although not the most efficient way of making oxygen, it is a way of making oxygen. Now, I promised some fines and pop.
I remember this one. I remember this.
Matches.
Oh, I was you're looking.
So what I've done, guys, is I've put some methane gas, hopefully enough, into that can. The can's got a hole at the bottom, that's where the methane gas went in. It's got a hole at the top, which I'm going to set fire to the gas. Now, there's a little flame at the top, and what happens is, as the methane gas, look at that, don't look at me, as the methane gas gets used up, oxygen goes in the back, and it explodes like that. And that is, you're going to... and it's...
You're forever being alone.
Yeah.
Why are you such an amazing soprano? Good. Keep believing. That's all he's good for.
Okay, so I've got some sugar here, made out of carbon, hydrogen, and oxygen. Okay, and what I'm going to do is I'm going to put some concentrated sulfuric acid. So, concentrated sulfuric acid has many properties. One, of course, is being an acid. Another one is it is a dehydrating agent. So it will actually take the elements of water out of things. Okay, so it will try to take water out of the sugar. So it will take hydrogen and oxygen out, try to take that out, and therefore will leave carbon behind. Okay, so we'll just have a look and see if I can do that. Just mixing it up. As you can see, the colour is darkening already. You did this?
It was
Every time I leave. There we go. It's getting nice and dark now, so just keep an eye on that for a second or two. Yeah, you want to hit that. So as it's taking out the elements, hydrogen and oxygen, out of the sugar, it's leaving carbon behind, and it is very exothermic. And about 1 minute, 28 seconds, we should get all the carbon out. So many just practicals. I think I need a volume. The next one.
Yes, go. So I will sacrifice myself for good of science, the good of chemistry.
What science?
We're science.
Yeah.
I will just sacrifice myself.
Louise, volunteer Matthew.
I need a teacher volunteer, really.
Sweet.
I'm ready to blow up.
I'm not teaching. Okay. Well, we wait until you can finish. It's still going. It's getting there. Another about 2 minutes maybe.
It's like a message with someone kills this guy by throwing a pig at him. It's awesome.
Yeah. So I'm just heating this other chemical for another demonstration in a minute. Now, did anyone count from my 1 minute 28 seconds?
Yes.
Did anyone count?
No.
Was I overzealous?
Can we pretend we counted?
Oh. Who goes? Who goes, guys?
No, no. Oh.
Okay, so all of that now.
It's like
It's growing.
It's alive.
So, yeah, I kind of click it. And basically, all of that carbon is coming out, all the bubbles, gases are coming out, and it's forcing the carbon out into this very odd shape. And you could theoretically wash that and then use it as a fuel. Okay, but I think it would be highly reactive because it's got a huge surface area. With all the bubbles inside, you get cavities inside, and a huge, huge surface area.
It does as well.
It's actually rock hard as well, and it's very, very hot. So that's an example of. So you think about it, sulfuric acid burns and it tries to do that to your skin, yeah, okay, as well as breaking down the links in all your proteins. That's why you should always wear gloves with these things. Okay, let's just.
Oh no, there it goes.
Wait a minute, it's still going? Oh, it's still going, isn't it?
Totes a max.
Cool.
Go Tyrone. Go Tyrone.
Yeah.
I named this Tyrone.
Right, Michelle and Louise, right, come here, please.
No, it's Tyrone. It's Tyrone. Tyrone's already. No.
Okay, so. And Benny, you got some split. So, what we're going to do, guys, is. Okay, so very simply, I've got a bubble solution here. Okay, and I'm going to. We've got some more bubble solution ready. Where is it? Is it like that? It's behind the yellow. Okay. So, what we're going to do is I'm going to get some methane gas.
Yes. Freshly made. By you. What? Freshly donated by you. How did tenner you donated? You're here. There's a bit of malfunction.
Okay.
Oh, I didn't make it.
I'm sorry. Right. So there we go. Right.
Yes.
Okay, there we go.
You love it, man.
Right, okay. So the way this works, guys. So I get some bubbles like so.
Bubbles.
Okay.
The Italian guy making coffee.
I get some bubbles like so, guys. And I should be able to flick them up or set fire to my hand like so. Okay. So Michelle, that's what you're going to do, Louise, okay? So I suggest what you do is wet your hands a little bit first. Okay, just get a bit of water on. Going back to the other demonstration with the £5 note. And put some on your hands.
No.
Arm's length.
Projector on fire, but that's
So what it should do is, so ideally what we're trying to do is, I think my hand, we can't fire it like that. Okay, so that doesn't go, Louise?
I think so. Each hand wants to go. I don't want to go.
Arm's length again.
You want to go?
I want to set fire to
Michelle? Thank you, Louise.
Michelle, get loads of bubbles. It's in the name of art, firebending. We can firebend with bubbles. Yeah.
Oh yeah.
I need more bubbles.
Bending with fire.
That's it. Arm's length. Okay, now, of course, what we're doing, of course, is doing a controlled explosion, a controlled use of fire. That's the only way we can really do it, otherwise we're not allowed to really. I'll give that to your paper. So, taking that a stage further,
Max, what are you doing? I can't think.
so the year 10s again will appreciate this, that I've got on the year 11s will. I've got some chemicals here. I've got another flammable chemical here, solids here, flammable chemical. So all I'm going to do is just slowly pour this flammable chemical on the bench everywhere, like so. Like so, okay? And then obviously I'm just going to set fire to it. Like so. And then of course you get this lovely series of colours. Now, to the intense colour, but maybe I didn't.
Sodium.
Copper, potassium, barium, yeah, it's barium.
So you got copper here, I reckon. Copper,
No, is that barium?
calcium. No, that's copper. I think. Yeah, there's a bit of lithium, sodium. Beautiful.
Beautiful. Enjoy the chemistry.
So of course, if you think about firework night, that's essentially what we're doing is what you happen on firework night. Okay.
Too much light.
Is that what we're gonna So let's do this other one now. Let's see how we get on. So I'm going to get these right here, guys. Okay, so, ooh, shoot. That's fine.
I'm not into it.
And then, bit of luck. So, how are we getting on there? Almost there, aren't we? So I think this is going to be our last one, isn't it now? So this here is another example of doing a controlled exothermic reaction in the lab. And in order for it to work properly, I need to melt this chemical here. And it won't take too long. What I need, Granny, is that a screen up again in the front, please. If I don't get this hot enough, it just won't work. So.
Yeah, that's what I do.
So I've got, this is, for those of you who this is potassium chlorate 5, okay, which is an oxidizing agent, it oxidizes things. And I'm going to put a jelly baby into it,
Yay.
which is basically sugar. So we'll try to oxidize the sugar.
No, you don't.
Has it gone?
No, it's one next to it. Cool.
Oh, yeah. Right, I'm going to make sure it's boiling hot.
Yes. Max, put the stool down. You do have a stool. Well done.
Okay, ready to do like.
Bad night.
One jelly baby.
why jelly beans are really that good.
There we go, guys. I hope you enjoyed it. Thank you. I suggest the smoke is hot. That's why it's at the top of the room.